Hello, my name is Sevi. I just released OSCToolset as an open source UnrealEngine plugin. It basically will simplify the OSC workflow for you. It makes it a lot faster and a lot easier to set up. And here I'm going to show you how it works. OSCToolset is in essence an extension of the OSC plugin from UnrealEngine and is packed with features. It automatically creates a server and the client, so you don't have to do it. It has modules that are data-driven. They are basically structs that you can set data, and it's a lot easier to manage. It will have automatic tick interpolation as long as the value type allows it. It also works through a router interface that you can implement and fetch any function and value in any context that allows it. It has some filtering, which is usually not needed because of the way we add receivers. And it also has like a runtime settings menu, which is super useful, as you can change the settings of the client and the server and other things directly on the runtime. All in all, OSCToolset is kind of the result of using OSC and kind of fixing all the hurdles of actually having to create certain things, and it basically makes it a lot simpler to work with OSC in UnrealEngine. Before diving into examples a bit more in depth on how it works, I want to show you a comparison between the base OSC plugin and OSCToolset. Here you will see that OSCToolset is commented in purple, so I will show you the differences on setting it up, and we will compare how it is for receiving data and sending data. One of the most common things that you will see is that most of the examples will show you to create an OSC server in any blueprint. Commonly, all the examples will create a server. It will store it in the references, and then you will bind to get OSC messages on that specific blueprint. In this example, it creates an event and it's going to be routed here. And then we can dispatch all the OSC messages and basically format them, parse them, switch them, and get the values. Right out of the bat, OSCToolset doesn't have a server setup. If the plugin is enabled, it will automatically create a client and a server in a game instance. The only setup that we have to do is that we have to register receivers in the blueprints that we want to receive data. A receiver is just a data structure that can contain an address, a type, and other settings that will set its behavior. One of the main features is that you will no longer need to generate and make different data types. For example, imagine that you want to set a location for a sphere. With the old OSC plugin, you would need to get specific floats at different indexes in your message and then construct a vector in UnrealEngine, which then you can use as the data type. With OSCToolset, that's greatly simplified, as the formatting of the address will dictate where that value is going, and then you can just route it through an interface. Formatting the address is something we do before sending the data to UnrealEngine, and that will be in any software that you want. OSCToolset expects a specific formatting structure, which you can see in the screen, and that will help the tool to give you the property that you are looking for. The way it works then is that you implement an interface called OSCTrouter, which here is already implemented, which gives you an array of functions that you can get. For example, if you want to get a rotation and you format it properly, you will get the rotation value already parsed. Another great feature of OSCToolset is tick interpolation. Some of the modules have a tick group where you can enable it, set the interpolation speed and a tolerance value. In this case, vector3 does have a tick group, but if we would set it to an event, it doesn't. This is reserved for most of the module types that can actually interpolate. For example, a vector3. In this tick example, I've set up a receiver, which is a vector3, which is listening for a sphere location. It's a vector3, and it has an enabled tick. If we look at the actual result, you will see that the purple sphere is at the base OSC received message, and the green one is a interpolated one. Another improvement is on the senders. In this example, I compare how you will set up sending data with the base OSC plugin and with OSCToolset. Just like before, the comments in purple represent the OSCToolset part. Just to look how it would work, if you would use the base OSC plugin, you would create a client, you would store it as a reference, and then you would basically send the messages. OSCToolset already has the client set up, so you don't have to do anything. On this example, I'm checking if my character is valid. This is checked in a parent blueprint, where if the character enters the box, will become valid. When that character is inside the box, there is a sequence, and the first part will be sending it with the base OSC plugin, and the second one with the OSCToolset. You can see that sending specific types in OSC is quite cumbersome and it requires quite a bit of boilerplate. For example, to send the character velocity, you would first need to convert a string to OSC address, set the OSC messages to that address, so you would make a specific struct. Then you would add a float, and here I have this simple function that gets the velocity. You would then send the OSC messages and clear the OSC, otherwise it would float the whole sender. It's the same for the location. You would just need to get and break the components and stack all the components and create the message that represents what you want to send. With OSCToolset, instead, you just can send a float, a vector tree, or a rotation. It's that simple, honestly. You set the address that you want to send it, you pass the value of the thing that you want to send, and all of these will be created for you. As I mentioned before, this is only sending when my character is inside this box. So you can see that in the left, I have a TouchDesigner, I have 2 listeners, and when I enter, all the values are being sent. You can see the difference is that the first one is using this OSCToolset formatting address, where you can parse it and just use it a bit differently. Something that is also managed for you is the debugging of the incoming OSC messages and quite a bit of logging as well. You will not have to create your print logs. It's all already done for you. And let's look at how this debugging example is working. I'm going to open it. And this is extremely simple. We are adding a receiver called sphere location, again, vector 3, and we just set the debug to on. Rather than having to print everything, you can manage your logs directly from here. So you can toggle it off, and if we will look at it, you see that now it's not being logged. You have quite a few options, just like you would with your print string. For example, the debug duration. It also uses the key, so the formatted address, so it doesn't flood your screen as it would if you would just use a print string without the key. And we can add the print to the log and to the screen, and you can give it a color that you want. By default, it will use the module color. If I open the output log, you will see that it's also logging there because we set it. I will take off this print log and I will restart this as setting it to white. If we start and stop, we will see that the log will contain all the data related to OSCToolset. There's also a lot of other logs, so you can filter by category, you can take everything out, and you can scroll down to OSCToolset, and here you will have everything filtered for you. There is quite a bit of information, like if it was initialized successfully, what addresses are we using, what clients are we opening, what receivers did we add, and everything else in between. OSCToolset also comes with a specific menu, which is extremely useful. You can press Ctrl-Shift-O and it will open this pop-up here. You don't have to do anything. It works as well, just like the client and the server. It works via a subsystem. You don't have to set it anywhere, so it kind of becomes a global menu. It's useful if you want to reinitialize, change the server address or the port while you already have packaged your game, which happens sometimes. With the comparisons being done, I'm just going to show you now how you could send like a float from TouchDesigner to UnrealEngine without anything, formatting the address properly and setting up Unreal. I already installed OSCToolset. That's you just make a folder in your project called plugins and you copy paste it there. Here you will see that it's already enabled. And this one will automatically enable OSC. It's a dependency. It's already there. You will see that. Usually what you need is to create a sender software that you choose. You want to send some data and you want to receive it in UnrealEngine, right? What we're going to do is basically to create that in the TouchDesigner, which is going to be super simple. I'm going to send a constant, and this is already a value. And I'm going to bring a OSC out because it's that simple in TouchDesigner. And that's actually kind of it. We have to format the address now. We have to say where do we want to send it, at what value it is. As we've seen, it matters to send a specific address. The format of OSCToolset starts with a OSCT. Then we add a role type. It can either be a R or a S. R is for receiver. And we have to think of what do we expect to do in Unreal, right? We want to receive a value, so we add an R. Then we give it a type. In this case, it will be just a float. And then here we will say it's a channel, or we can call it scale. Then what you have to do is to set up like the OSC server out from TouchDesigner. Where are we sending this data? I'm doing it all locally. So we set the address to localhost, which points to the same machine, and we set a network port. By default, OSCToolset is listening at 999, and then you just set that as a port. That's the setup for TouchDesigner. Wasn't that easy? Yeah, right? Then in Unreal, you would just create a blueprint or an actor or a widget, something that you want to receive that value at. And I will just do it as simple as I can. I've done this example a million times, and now will be 1,000,001. And I will add an actor called BP sphere. I will open it, and I'm just going to add, you guessed it, a sphere. I will compile it, I will save, and I'm going to drop it into the world. By default, nothing is happening here. If I play, you see that nothing is connected. We kind of have to connect that value, right? We need to tell to the sphere, hey, you have to receive the scale. That's extremely easy. As I mentioned before, we don't have to set up anymore any clients or servers, so you can delete these values. And what I'm going to do here is to add a receiver, because that's what we want to do. You want to add a receiver, and what I'm going to do is to promote this to a variable, and I'm going to call it scale. Once you compile, you will see the values of that receiver here, and we can set them. By default, it's set as a float, quite convenient, and here I'm going to say it's at a scale. If I compile and I'm going to play, you will see that it doesn't work. Oh, what could happen? If I go to the output log, you will see that it will tell you a warning. This will be for any actor that didn't implement the router. It's going to tell you. So here we can read, the BP sphere C1 needs to implement OSCT router interface. Thanks for the reminder. And we are trying to receive this address. So we can stop that, and we implement the interface. Also extremely easy. In your actor or object, you go to class settings, you go to interfaces, and we add a router. If I compile and I save, you will see that nothing's happening, but we don't get a warning. Pretty good, right? Great. There's a few things we can do. We could, for example, debug that value. We can print on the log on the screen, see if that is coming in and everything is working. I am obsessed with saving, that's why that's happening. And you can see that it's already being sent. You can see that when I change the value, it's constantly sending. It is constantly sending because of the way the OSC out of TouchDesigner is being set up. Here you can see it's being sent every cook. A cook, you can see that is happening at the constant frame rate of 60 frames per second. If you toggle this off and clear the log, you will see that now it stops sending and it will only be sent when the operator cooks. Great, then the value is actually connected. We only had to add a receiver and implement an interface, and now we are just left to actually do something with that value. And that something can come from this implemented interface function, which we can find here as OSCToolset. We are actually receiving a float, and we can get a float. Now, my favorite is just to change the scale. And here I'm going to say set a scale. If I can type, of course, let's say set the world scale in 3D. And although this is a vector, we just want to set it uniformly, and it works for now. We compile, and if we connect it, you will see that we are changing the sphere size. One thing to notice is that we are just receiving and getting like the value at which we are sending. You can see like that. But we are not interpolating. So how can we interpolate this change of scale? Well, that's done by, as I mentioned, is to enable the tick. Floats are actually tickable. We can interpolate, kind of funny, tickable. We can enable a tick on a float, and basically it will allow and enable the interpolation. And if I compile and I do it, it will see that it's not going to work. Why? It's because we have to use the actual float tick function from the router. If I change the way that this world scale is set, and I actually use this event, this is what's going to be on the tick time. I will take this away. I can delete this value of the float. And now I'm using the float tick. And when I compile, now we will be actually sending the interpolation. You can also change the interpolation speed, for example. If you want it slower, you can put a lower number. You will see that it will be quite smooth to actually transition. And if you want a snappier value, you can set it to 10 or 15, for example. That's extremely useful because let's say that your TouchDesigner or whatever software is kind of lagging out a lot. And we can try that by hogging the TouchDesigner instance. So I'm going to bring that to like a pretty bad frame rate. You can see that now it's 10 frames. But this in Unreal, it will not affect the way that it's going to interpolate. By setting such a fast interpolation speed, you can actually see the jumps. But if you just give it a normal value, you will see that it actually separates the concerns. Super useful. With the open source release of OSCToolset, I've created a set of basic examples that hopefully will help you getting started and see the possibilities of connecting other software to Unreal, and it will help you maintain the tool over time. These basic examples are purchasable and connect Ableton, TouchDesigner, MaxMSP, and Python through the same two addresses, and they are implemented in 3 different levels in UnrealEngine. They are extremely basic, so they implement a button and a slider, and that button and a slider will behave differently for the 3 different UnrealEngine examples. Examples basic contains 5 folders, one for each different external software and one for UnrealEngine. Inside of Unreal, there are an examples folders, which are content plugins that you can basically add in any project that you are working on. This is an empty UnrealEngine project that I created, and because I just copied the plugins, you can see them here. If you don't, you might need to actually check to show the plugin content. You should be able to see 3 different plugins, the C++ OSCToolset. This is the main brain that you will always need if you're going to use it. And then we have 2 different example folders. If we look at the basic examples, we will see there are 3 folders with the 3 different levels and also a data table. This data table is served as a profile that stores the basic addresses. For example, we have the basic trigger set as an event, and we have the basic strength set as a float. What you can do then is to open the particles and open the blueprint as well. All the different examples are the same. At begin play, we add receivers from a data table. That's the one that we just saw. And then they implement it in a specific way. This particle example is using the event to make a pulse for the particles, and it's using the float and the strength to change the intensity. If I play, nothing really happens. There is no way to control it. So it's up to you to choose what software you would like to control this from. Once open, I'm going to put them side by side, and you will see that it already starts to function. So what's happening technically is that we send, as we saw in the example overview, the specific address for the event and the one for the float. As you just saw, you can actually control these 3 different examples in UnrealEngine through these 4 different programs that you can make more if you are interested to send it from anywhere else. The only thing it's necessary, and as you will see in the settings and the other examples, is the actual formatted address. Then UnrealEngine and these examples will handle the rest. These basic examples also include these bare examples where I was showing the comparison between the OSC and the OSCT receivers. And if you have the OSCToolset-TouchDesigner, you will also get this updated. You will find it in the downloadable files. In order for this to function, you will have to open the according TouchDesigner file. That's where I created this bare examples plugin. I would also like to mention that I have a custom component for OSCToolset built in TouchDesigner. It solves a lot of the issues that you might run into when you want to try to send this data. And it implements all the receivers, all the senders, and works really well. A lot of people have been using it, and it includes quite a few examples that I will leave a link so you can look at it. It's a separate purchase because of how much work this all actually took. It was kind of insane. But you can see that it does have its own set of examples. For example, it has like the audio reactive example. I try to structure it a little bit the same. And my intention is trying to monetize examples so that I can maintain this tool, because it does take quite some time. It also includes packs, which I didn't even have time to go a bit too much in depth because I wanted to keep it basic, but maybe for another time, another set of examples that I can go even deeper within the toolset.